Hi guys, it's Miss Van Dyke and welcome to your first set of notes. Today we will be doing 1-1 on variables and expressions. Before we get started on our notes, make sure that you have this document. Go ahead and save it as a PDF in Notability or print it out. I recommend that you print it so that you can look back on it later when you're working on your iPad. Now that you have the notes up, go ahead and put your name on it and the date. And our objective of the day is that you will be able to write algebraic expressions. I have 3 non-algebraic expressions here, and I'm looking for different ways that you can say hello, I love you, or goodbye. You can say hello by saying hi, or what's up, or how are you, or hey, how's it going? Things like that. But they all mean the same thing. These are all greetings. Alternatively, you could say I love you, like I like you, or you're so sweet. You can say I love you by sending someone a heart. You can tell your mom you love her by doing stuff for her, by acts of service like cleaning up your room, or by listening to her. You can say things, you can say goodbye by saying like, see you later, or until tomorrow, or bye. I have a cousin who likes to say like that. She goes, bye, with like a million E's. But they all mean the same thing. They all mean like farewell, I'll see you later. So while they look different, they mean the same thing. They have the same meaning. So today we're going to look at different expressions that have the same meaning. But before we do, I want to go over some key terms with you. The first key term is quantity. A quantity is anything that can be measured or can be counted. That is, it's represented with numbers. In fact, some quantities can change and others remain constant. So some quantities are always going to be the same, but some of them might change. A variable, you see that word in there, vary, as in not like V-E-R-Y, but like V-A-R-Y. To vary is to change. So a variable quantity is something that can change. In math, we represent this with a letter, usually N or X or A. An algebraic expression is our next term. Algebraic expression is a phrase that includes at least one variable, usually X or N again, at least one variable. And then finally, a numerical expression is one that doesn't have any variables. That is, it has numbers. It might even have operation symbols like plus, minus, times, divided by, parentheses, square root. It might have those kinds of things, but it won't have any variables. I don't know if you can see it, numerical. It's like like number. That's where it gets its name from. So quick, go ahead and pause the video and explain to me what's the difference between an algebraic expression and a numerical expression. Hint, an algebraic expression and a numerical expression are right here. Now that you have that explanation done, we're going to give 2 examples of algebraic expressions. So remember, an algebraic expression has a variable in it, so 32 more than a number n. That is 32 plus n, whatever n is. And then an algebraic expression for this one is 50 less than a number n, or n minus 50. We have 2 more. 8 times a number n looks like this. 8 times n, or You could do 8 times n with a little dot. My favorite way though, because it's the cleanest and the quickest, is 8n. These all work. You remember that quotient means divide. That gives us n divided by 5 or n over 5. Those are all great. Go ahead and pause the video and see if you can put both of these into practice. Okay, our first one gives us 3 plus 2x. Our next one is 6 over x minus 9. And finally, we have 4 times x plus 7. Now, how would you represent 3x? I mean, I guess if you want to be pedantic, you could say 3x. But that doesn't tell you what it means. You could say 3 times a number x. That works. You could also say the product, the product of 3 and a number. You could say and a number x or just a number, both are fine. So just like in our intro, we had a bunch of different ways to say the same thing, just like hello, hi, I love you, I like you, or I washed the dishes for you, or goodbye, well, see you later. These are all different ways to say the same thing. Now, we have a problem and we want to try to represent it with an algebraic expression. So here we go. In example 5, the table below shows how the height above a floor of house of cards, remember a house of cards is something that looks like this. If you have one card and then you put another card next to it, you make a triangle, and then you can make another pair like that, and then you put a card on top. That's one layer, 2 layers, looks like that. So we're trying to measure the height depending on the number of levels. So look at this chart and what do you see? First, actually, let's switch these. What stays the same? What is constant here? Well, things that stay the same are this 3.5. This 3.5 is constant. Also, this plus 24. This is the same all across the board as well. Why do you think that is? Well, it might be that the cards are 3.5 inches tall. Maybe the table is 24 inches tall. Maybe they're sitting on a table like this. And this is 24 inches. Maybe? I don't know. Okay, so that's what stays the same. Now, what is changing? We're noticing that as the number of levels changes, its height is changing. Oh, hey, look. We see the levels inherent in the expression too. So that's really cool. So the general rule, we're going to write the general rule by keeping what stays the same, and then we're going to represent what changes with our variable, because it's the thing that varies. Remember that changes is the same as varies. Because it's changing, we're going to make that our variable. Here they have the variable n. I think we should just keep that same variable. So there you go. So we have n here because that's the thing that is changing up there. And we're going to keep everything else constant. So we have 3.5 times n plus 24. And that's our expression. So our final answer is 3.5n plus 24. That's it. That's our whole lesson. We have two kinds of expressions. We have algebraic expressions like this one because it has a variable in it, something that changes. And then we have numerical expressions, which are way up here. Did I even give an example? I didn't give an example of a numerical expression, you guys. An example of a numerical expression is something like 5 plus 8. It's an expression. There you go. All right. Numerical has numbers. Algebraic doesn't. Go ahead and fill out what you think is the most important thing or question you have, and then make up a quiz question. Have fun on your homework, and remember to show your work. Hope you have a great day and you have lots of fun.